in our next lesson, we're talking about congruence criteria for triangles. In our last lesson, we talked about the angle-side-angle triangle congruence criteria, meaning another way to show or prove that two triangles are congruent without giving a sequence of rigid motions that show that congruence, that we can say they're congruent based on sides and angles. In this lesson, we are building upon those ideas and giving two other congruence criteria, specifically the ASA, or angle-side-angle, and SSS, or side-side-side congruence criteria. Just so you know, there are other triangle congruence criteria that are mentioned in a future lesson in Engage New York, but these three are the ones talked about in our standards, and so I will focus on these three: side, 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 angle, side, angle, and side, angle, side from our previous lesson. This lesson will focus on this CCRSM standard to explain how the criteria for ASA and SSS follow from the definition of congruence in terms of rigid motions. And even though it's not stated here, we'll talk about using these to prove that triangles are congruent. And in future lessons, we'll talk about using triangle congruence to show other properties from constructions and about parallelograms. Let's get started. The first congruence criteria mentioned in lesson 24 talks about angle-side-angle triangle congruence. And I'll just draw a picture here. If you have two triangles where you have a pair of angles that are congruent and a side that's congruent and a pair of angles that are congruent in this order, so a side, an angle, and a side, or better yet, a side and the two angles that are adjacent to that side, then the criteria is that those two triangles must be congruent. And the proof of that, now they don't start at the very beginning of the proof, they kind of build on what they did previously for side, angle, side, using a set of transformations. They first would use a translation to translate them next to each other, and then rotate them. And once you rotate them, you would have this picture right here. And then their goal is to use a reflection over AB, reflect over AB, and say, look, they're congruent. Now, they do go into a lot of detail with proving that C is equal to C triple prime, that I won't spend a lot of time with. But the proof is based on rigid motions and mapping ABC, or I should say ABC triple prime, onto C, and that will show the congruence. Now, to give you an example of angle, side, angle, I want to go to the exercises and do number 1. M is the midpoint of HP. We are given that M is the midpoint of HP. We are also given that the measure of angle H is equal to the measure of angle P. Now, I mentioned this last video, but it's very, very, very important that you draw on the diagram as you do these. If you don't draw on the diagram, you won't see where to go next. So I will draw that angle H is congruent to angle P, and that's all I have for now. So in every proof, we start with the given. Now, one next step that I like to do is to kind of flesh out or talk more about what is really given in the diagram. So what does it really mean that M is the midpoint of HP? Well, what that really means, if M is right in the middle of H and P, that means that HM has to be congruent to MP, and those are sides in my triangle. Okay, now the next question is where to go next. What other things, we've used everything in the given. I next look at the diagram. So what in the diagram can I use? And hopefully you see that we also have a pair of vertical angles. Whenever they're touching at an angle and you have vertical angles, that's usually going to be useful to you in the proof. And so I know that angle HMG, using 3 letters, the middle letter is the vertex, HMG is congruent to angle PMR because they're vertical angles. All right, and I did draw on the diagram, which is very important. And then I look at the triangles and say, well, why would they be congruent? Hopefully you see an angle, a side, and an angle. See an angle, a side, and an angle, and an angle, a side, and an angle. Or better yet, a side with the adjacent angles congruent to a side with adjacent angles. And so I can say that these two triangles are congruent by the angle side angle triangle congruence criteria. And that's the whole proof. Let me point out really quickly that it's very important that H corresponds to P, and M corresponds to M, and G corresponds to R, and that I write this congruence according to what actually corresponds to each other. But that is the whole proof of proving that these triangles are congruent using the angle side angle triangle congruence criteria. Next, I want to go back up and talk about the side congruence criteria that's mentioned right here. Again, I'll draw a picture. So if I have two triangles and I have all three sides congruent to all three sides, this to me pretty logical to understand that if all three sides are congruent to all three sides, then those triangles must be congruent even without showing the rigid motion. The proof of this, again, we don't start at the very beginning of the proof, but we do some translations and rotations to get them into this configuration. And then we do reflect over AC just like before, and we prove that B prime is going to line up perfectly on B. In other words, that these two triangles will have to be congruent if we have the side configuration. All right, now let me give you one example of side, and I'm going to use number 2, but I'm going to kind of add to it or change some things about it. The problem I have with this question is that we've not really proved properties of rectangles. That's coming up in a future lesson, and so I'm hesitant of what Engage New York thinks I can use and thinks I can't use about rectangles. So I'm just going to change this whole question, but use the picture. So instead of that, I will say that we're given that JK is equal to LM, and we'll be given that JM will be equal to LK is given to us. Okay? And our goal is to prove that the triangles are congruent. Well, we will start off, as we start every single proof, with the given. And it's very important that you draw on the diagram, otherwise you can't see where to go next. JK is equal to LM, and JM is equal to LK. Now I've used everything in the given, and now I look at the diagram. What else in the diagram can we use? Well, I notice that MK is overlapping on itself, and so I can use the reflexive property to say that MK is equal to MK. All right, so I now look at the picture and say, hey, I have all three sides of one triangle congruent to all three sides of the other triangle. So by the side triangle congruence criteria, these must be congruent, and I'll write the congruence criteria using the right correspondence. The first one doesn't matter so much. The second one must match the first. And that is the whole proof, proving that these two triangles are congruent. Now, to give you a heads up about the future lessons is that we will frequently prove that triangles are congruent and then use that to say, well, if that's true, that some corresponding sides or corresponding angles must be congruent, which will help us prove properties of parallelograms, properties of rectangles, things about constructions that we've used in past lessons. That's kind of where we're going after this lesson, but that's all I have for you. This lesson was about angle, side angle, and side congruence criteria, and we will use these over the next several lessons to prove more things about constructions and about rectangles and about parallelograms. So stay tuned. Thanks for watching.